All right, this next example gives us the function, the cubed root of x, and wants us to use a Taylor polynomial of degree 2 around the value of 8. All right, so our first part to this A, what we're going to want to do is find all those derivatives. And then what we're going to need to do on this one is find that around 8, because that's the value that they asked us to do on this one. All right, so we're going to want to find the original function, first derivative, second derivative, because we're doing a degree 2. I'm going to go one further in finding derivatives, though, because when we hit our next part with our error, it's the next one up. So I'm going to also find that. All right, so let's go through and find these. Original function is just cubed root of x here. So what is cubed root of 8? And put that in your calculator, but you should get 2. All right, now when finding derivatives, we're probably going to want to think of this as x to the 1/3 when doing that. So if we use our power rule here, bring that down, subtract 1 from the exponent, we get 1/3 x to the negative 2/3. We want to figure out what is that at 8. So we're putting 8 in here. And you can use your calculator. But if you do that, it should come out to equal 1/12. All right, next one, again, bring down the power. So now we got negative 2/9 when you multiply negative 2/3 and 1/3. X, and the new power would be negative 5/3, because we got a minus 3/3 from 2/3 to get that. So now we got to plug 8 in there and find out what that one equals. And in this one, if you do that one and use your fraction key, you should get negative 1/44 is that value. I'm going to go one more derivative. We're not going to need this value at 8, but I do want to find it. So if you would apply this one more time and bring down that exponent, we're going to get positive 10/27 x to the, if we minus 3/3 from this, negative 8/3. Okay, so now next, let's figure out what our function is. Remember to find p of n here. It's the summation from n equals 0. Well, maybe I should use a different variable here. Let's say k equals 0 to n. And then we're doing this with k factorial here. This is going to be our derivative at k evaluated at our a value, which is 8. And we got x minus our a value to the power of k. All right, so if we put 0 in, 0 factorial 0, anything to 0 power 0. So all this is going to equal is our value we had for the derivative at that, which is 2. Plus, if we put 1 in now for k, it's going to be our value we had here, 1/12, over 1 factorial, which is just 1. And then we're going to have x minus 8 to the first power. All right, if we plug in the next value, 2, it's going to be our derivative value. So negative 1/144 over 2 factorial. And then we're going to have x minus 8 squared here. So that's our polynomial. Just simplifying it a little bit here, you'd get 2 plus, I'm going to write this as x minus 8 over 12. This one, next one's going to end up being negative. 2 factorial is 2, so if we take half of 1/144, that's going to be 1/288. And then I'm going to put that x minus 8 squared in the numerator. So this would be our second degree Taylor polynomial for cubed root of x. Okay, that approximates that out to degree 2. All right, so that's part A. That would be our answer there. Part B now, they want us to find how accurate is this approximation. So they want us to do the error, the Lagrange error for this one. So part B now, our Lagrange error that we talked about, our R2 here, it should be less than or equal to our M value over K plus 1 factorial, and then this would be X minus our A value to the K plus 1 power. So in this problem, if we're using 2 for, well, let's write this first as N here. If we're doing this as 2, so now we'd be plugging 2 in for all those K values or N values, however you want to think about this. So this would end up being now our M value over 2 plus 1, or 3 factorial. And in this problem, our A is 8. And we'd have 2 plus 1 as our power, which is 3. To get our M value, remember we get that by, our M value should be less than or equal to the absolute value of the N plus 1 power at whatever value is going to be the biggest on our interval. So first we know that in this problem, this would be, if we're doing it at 2, that we're going to have this to the third derivative of this at z. So we want to find the third derivative at z, and z is going to be whatever value makes this the biggest. Well, we found that third derivative. It's this. So we want to know what value is that going to be biggest at now. So we're using 10 over 27 x to the negative 8 thirds. What value of x is going to make that biggest here? And our interval on this one is centered at 8. And if we look back up, they said, where is it biggest on, where is this biggest on 7 to, so this one, if we go back up, yeah, this, where is it biggest from 7 to 9? So on that interval, where is this value going to be the biggest? Well, if you were to graph out this function, it's a exponentially decreasing function that we can plug in here. X to the negative 8 thirds. So if we graph this one, there's the left side of it, but we're interested what's it doing on the other side here. You can see it's an exponentially decreasing graph. That's going to go towards 0. So where's it going to be biggest? Well, if that's trending downwards here, here's our interval from 7 to 9. This is decreasing, so it's going to be biggest at 7. So the value that we'd want to plug in here to see what the largest it could be would be 7. So our f2 here is going to be what this is at 7, which if we put 7 in here, we can use calculator to approximate that. So on our calculator, let's put that value in. So it's going to be 10 over 27, 7 to the negative 8 thirds. So the largest it can be is like 0.002, and just to be safe, let's make it a little bit bigger. So 0.002 1 if we do it out to 4 decimals. So we know it's for sure less than that. As long as we're bigger, we should be okay. So that would be our m value over 3 factorial. And then with this, they want us to find that on our interval here. And then we're looking what's the absolute value of x minus 8 to the third power. They're asking on this one between 7 and 8 again. So that value, if we're doing between 7 and 8, that means, or sorry, 7 and 9, that means this value's centered at 8 would always be 1 off. So this is the value of this is going to be 1 to the third power because it's always going to be within 1 of 8. It's 1 on either side. So now we just got to simplify that. Well, that's basically our m value divided by 3 factorial, which 3 factorial is equal to 6. So if we take our answer here divided by 6, should give us an approximation of this one. That is going to be, that's a scientific notation number. So it's going to be less than, we'd have to move that decimal point over 4 times to the left, which means there's going to be 3 zeros after the decimal. So 0.0003, and I'll round that off there to 5. So our error here should be less than or equal to that, which means that's how far off our approximation is going to be. All right, I want you to try this next one here. They give you a function, and they tell you that the fifth derivative of this function is 4 cosine x. If the fourth degree Taylor polynomial of f about 0, so it's a Maclaurin one, is used to approximate f on the interval from 0 to 1, what is the Lagrange error bound for the maximum error on this interval? So all you're after is the error on this one. I want you to pause and try it out and see what you get. All right, let's see how you did. So for this one, if they want that fourth degree one, that means we're finding the Lagrange error of 4, which means we should do 4 plus 1 factorial. 4 plus 1 should be our power. It's about 0, so we should be doing x minus 0. And then we need our m value. That'll turn into 5 factorial and 5, and that'll just be x. To get our m value, we got to take the 4 plus 1 power of this, because we're doing a fourth one, but you got to go up one. So it's the fifth derivative at the z value that's going to be the biggest. Well, that's why they told us this. The fifth derivative is equal to 4 cosine of x. And so we got to figure out where on the graph between 0 and 1 is that going to be the biggest. You can do that by graphing. So if you graphed out 4 to the cosine x here, so if we graph that, you can see, I graph this on the trig graph, you can see that the biggest value it's going to have from 0 to 1 is at 0. So we're looking just between, actually 1 is going to be over here a little bit. Between 0 and 1, the biggest value is going to be at 0. So if you put cosine 0 in there, cosine 0 is 1, which is 4 to the first power, which means it's going to be 4. So 4 is our biggest value, so we got 4 there. And then what are we plugging in for x? We're estimating it for 0 to 1, so plug in 1 for x. And now simplify. 5 factorial is equal to 120, so you get 4 over 120 or 1 over 30. Our Lagrange error should be less than 1/30th of a value.